Okay, so we are here for the second lesson for Monday, July 10th. So just a reminder, go do that survey on the LMS. So I'm going to share the screen. So the first part is just an activity that I want to do with you. It's up to you if you want to do it. Not a big deal if you don't. So you're just gonna average or guess the average area of all rectangles on the page. So here, choose 6 rectangles before you calculate any areas that you think represent the entire population of rectangles well. Okay, so rectangle number. So you do 1, 2, 3, 4, 5, 6, and then calculate the area. And find the average. So after setting a new seed value on your calculator, using the randint function to choose 6 random rectangles for you. Okay, so you're just going to work through this, and by the end of it, you should learn that the design of a study is biased. So that is something that we're going to talk a lot about. There's always biases, whether you mean to or not. Your experiences and your values come into play for everything in your life. And it's not a bad thing by all means, depending what you do with your biases, I guess. So the design of a study shows bias if it is consistently over or under estimates the value you want to know. Random sampling is necessary to get a representative sample. So for example, if you're looking for specific people who have brown hair and you go and pick, 50 people with brown hair and 30 people with blonde, you know what your results are going to be. It's pretty self-explanatory and very biased. So when you have a random sampling, it's more representative of that data that you're looking for. Okay. The animals are driving me nuts today. He's like walking all over my screen and stuff. Okay, so we've got random sampling methods. So a sample is a simple random sample. If is selected so that each member of the population is equally likely to be chosen, and the members of the sample are chosen independently of one another. So when we have it very equal, so you could say like 50 women, 50 men, so those are equally chosen, and you can see like how many play sports or something. So every set of n units has an equal chance to be the sample actually selected. So for example, you put names in a hat and you draw until desired sample size, more commonly number names, and you use random number generator or other source of random numbers to select sample. So for example, you might see your teachers sometimes do the name selector, like wheel, or pick your name from like a popsicle stick, or there's different like techniques that teachers will use. So it's random and they don't have to, be biased and always pick on one student or whatnot. So systematic random sampling is if you randomly chose some starting point, then select every nth element. Okay, so for example, you say every second person is going to go pick up garbage. This guarantees that the sample is taken from throughout the population, but it requires ordered list of everyone in the population. So for example, if your teacher, it's common in like gym class, so they'll have like a class list and they'll name you out this person on this team, that person on this team, and it goes on like that, according to your ordered position. So that would be that it's from the class list, it's alphabetical order, and so on. Okay, so an example, if we wanted to get a systematic random sample of 10% of the students from King's, which has approximately 600 students. So you would calculate the number of students required for the sample. So if you need 10% out of 600, that gives you 60. And then you're going to calculate the sample interval. So that is your population size over your sample size. So that would be your 600 over your 60, which is 10. So this is a little bit messed up, so you might want to change that. I can write it down. I swear the animals are worse than kids. The cat's meowing because there's a bird outside. Okay, so let's see if this is gonna work. No. Okay. So population size over sample size is what you're supposed to be writing here. It's got the words, it's just all mumbo jumbo together right now. Okay. Then you're gonna choose a random starting point using a random number generator, and you're gonna include every 10th student from the randomly chosen starting point in your sample. Okay. Next, we've got the stratified random sampling. So when using a stratified random sample, the population is divided into groups, which are called strata. Okay, so that means that they are divided by age, by geographical areas, by grades, etc. So that example where they looked at grade 9 students who enjoyed the cafeteria, that would be called a strata. So the grade 9 class or grade would be called a strata. And I wrote it down. So a simple random sample of the members of each stratum is then taken. So the size of the sample for each stratum is proportionate to the stratum size. So you must survey the same percentage of people from each stratum. Okay. So for example, if you want a stratified random sample of 10% of the 600 King students, we can divide the population into 4 groups based on grade, and then take a random sample of 10% of each grade. So that is a stratified random sample. Systematic means that it doesn't matter the category, you're just getting a certain amount, whereas stratified would be each group, and then you take this certain percentage from each group. We've also got the cluster random sampling. So when using a cluster random sampling method, divide the population into groups or clusters. Randomly select a few of those groups and then sample all members from the selected group. Okay, so for example, we are looking at age. So you're going to split up ages between 0 to 10, 11 to 20, 21 to 30, so on. They are in groups, and then you randomly sample all of the members of one group. So let's say you pick out from a hat that you're going to sample people from 41 to 50. you're going to sample all of those members. Okay, so for example, randomly select 5 block C classes, survey all students in each class selected. Then we've got the multi-stage random sampling. So when using multi-stage random sampling, the population is organized into groups. A simple random sample of groups is chosen, then a simple random sample of people within the group are chosen. So for example, there's a lot of words that are all the same. So randomly select 5 block C classes, survey a random sample of 10% of the students in each class. So I know these are a lot of words all together. So I did put them together into a type of graph. So this will help you out. It kind of puts everything together into like a cheat sheet, I almost want to say. So it tells you what that means without so many words. Okay. So we also have types of non-random samples. So we have the convenience sampling. So the easiest way to obtain a sample is to choose it from, or choose it without any random mechanism. So that's called haphazard sampling. So choosing individuals from the population who are easy to reach. So, you know, the first person that answers the phone. Convenience sampling often produces unrepresentative data. So like, best example I could give is, you know, if you're doing the person who answers the first call, and you're studying like anxiety, for example, a lot of people with anxiety don't like answering the phone if they don't know who it is. And so it's very unrepresentative data. So for example, suppose we want to know how long students at a large high school spend doing homework last week. We might go to the school library and ask the first 30 students we see about their homework time. So it's a little unrepresentative because sometimes students will be there catching up on work and aren't very studious. A voluntary response sampling consists of people who choose themselves, so they volunteer to be part of it. So there are a lot that will pay you money to do their samples. There's actually a website where you do get paid for it by responding to a general invitation. Voluntary response samples attract people who feel strongly about an issue and who often want to share their opinion. So this often leads to bias. So if you're looking at like politics, you're not like, it's going to be an invitation type of sampling, and that's going to get a lot of like, I want to say Karens, or people that, you know, like to talk about issues and have very strong opinions. And so it's not a very randomized type of thing. And that is it. Okay, so you've got your independent practice questions. Again, it's relatively a short day. So if you are done, please submit anything that you have not submitted yet. Otherwise, go enjoy the nice weather. It's supposed to rain for the rest of the week. Okay, have a great day.